Electric eel, Electrophorus electricus. The electric eel has a slender, snake-like body and flattened head. Its thick, scaleless skin is generally dark gray to brown, and its underside is a yellow-orange color. Similar to other eel-shaped fish, the electric eel lacks pelvic fins. It has a small or reduced caudal fin and also lacks dorsal fins. Instead, an elongated anal fin helps it maneuver through the water, where it can swim forward, backward, or hover as it searches for prey. 3 specialized electric organs, the main electrical organ, the hunter's organ, and the sax organ, make up about 80% of this fish's body. Its remaining vital organs are tightly packed within the anterior, or front, part of its body. The electric organs create strong and weak electric charges, which are utilized for defense, hunting, communication, and navigation. Stronger electric charges can be energetically exhausting for this fish. Its strongest electric pulses are produced by the main electrical organ, as well as 2/3 of the hunter's organ. The remainder of the hunter's organ and the sax organ produce the weaker electric discharges. Size: electric eels grow to lengths of 6 to 8 feet, 2 to 2.5 meters. Native habitat. This species is widely distributed across northern South America. Its range spans across Brazil, the Guianas, Suriname, Venezuela, Colombia, Ecuador, and Peru. Electric eels inhabit the quiet, slow-moving waters of oxbow lakes, streams, pools, and flooded forests of the Amazon and Orinoco rivers, preferring side channels but also living further inland. Both of the rivers these fish inhabit are subject to a natural fluctuation of water driven by precipitation patterns, which results in 2 distinct seasons, wet and dry. The 2 seasons bring about drastic changes in available habitat for electric eels. During the rainy season, the rivers swell, reconnecting lakes and ponds as the forests flood. Juvenile electric eels disperse and expand into new territories. As water recedes in the dry season, large groups of fish become isolated in the pools and smaller streams that remain. The water in these areas is poorly oxygenated, but electric eels are specially adapted to thrive in this environment. They are obligate air breathers, which means they surface for air periodically. Their mouths are heavily vascularized with folds that increase the surface area, allowing them to breathe air rather than trying to meet their respiration needs through gills in warm, anoxic waters. Throughout the dry season, the electric eel is also at greater risk from predators, such as large mammals, that hunt from outside the shallow waters it inhabits. Because there is little space to retreat, the fish is often forced to defend itself. Water efficiently conducts electricity, providing a wide surface area for the electric eel's shock to be applied. This means that an electric pulse delivered through the water may not be as painful for a large predator as one delivered outside of the water. As such, an electric eel can instead jump out of the water, sliding its body up against a partially submerged predator to directly target its shock. The eel then delivers its electric pulses in increasing voltages. Lifespan. The average lifespan of electric eels in the wild is still unknown. In human care, males typically live 10 to 15 years, and females generally live 12 to 22 years. Communication. Electric eels communicate using low electric organ discharges. This electricity is produced in pulses, and the duration of a pulse is much shorter than the time that lapses between each pulse. The frequency at which weaker electric pulses are produced varies between males and females, as well as across individuals. Electric eels can detect these signals and interpret information about other individuals in the water. They can even convey information about their sex and sexual receptivity, which is important during the breeding season. Electric eels are not the only fish to communicate using electric organ discharges. More than 220 species of South American knifefish in the electric eel's lineage use this highly advanced method of communication and detection. Food, eating habits. Adult electric eels are generalist carnivores, eating fish, crustaceans, insects, and small vertebrates, such as amphibians, reptiles, and mammals. Juveniles feed primarily on invertebrates, and newly hatched electric eels will eat remaining unhatched eggs. In addition to defense, electric eels use their shocking power to hunt. In the dark and murky waters they inhabit, prey can be difficult to spot. To aid its hunt, the electric eel has motion-sensitive hairs along its body, the lateral line system, that detect any slight pressure change in the surrounding water. When the eel suspects a prey item is nearby, it emits two rapid electric pulses called a doublet. This doublet affects the muscles of the prey, causing it to twitch involuntarily and alerting the electric eel to its presence. With a series of high-voltage pulses, as many as 400 per second, it then paralyzes and consumes its prey. This entire process happens so quickly that it can be difficult for the human eye to observe in detail. Reproduction and development. Female electric eels lay between 1,200 and 1,700 eggs during the dry season. Males construct nests made of saliva and guard the larvae until the rainy season begins. This parental care may be the result of increased food competition and potential for predation during the dry season. More research on the reproductive cycle and behavior of electric eels is needed to determine exactly how spawning takes place. Some researchers posit that spawning occurs in successive batches throughout the dry season, while other accounts document that all eggs are deposited at once.